Hello everyone, welcome to my channel. From this video we are starting a new series that is oxidation reaction. So from today onwards we are discussing different type of oxidation reactions only. Okay, so this is the part 1 of the oxidation reaction series. So let's start. Now let's see. There is a various oxidation reaction which is important for any kind of competitive exams like CSI, NET, GATE, JAM, TIF or BARC. Okay, so in this video we are specifically going to discuss two different type of oxidation reaction, that is selenium based type of selenium based kind of oxidation reaction, and a very important name reaction also as well as oxidation reactions. Okay, so this is called COREY-KIM oxidation. So let's start. Okay, so for this video only we are discussing only two types of oxidation reaction. Okay, number one is selenium SiO2 oxidation, selenium dioxide oxidation, and two, that is COREY-KIM oxidation. Now see, this COREY-KIM oxidation is very much important for CSI, NET and GATE. So you have to know what is the mechanism, how the reaction works, what is the reagent of this type of reaction. But in selenium dioxide, you can see here that is selenium dioxide is the only reagent for this type of oxidation. Okay, now first discuss the selenium dioxide oxidation. So number one is selenium dioxide oxidation. Now there is a different kind of oxidation reactions are important for any competitive exams. This is part 1. So in this part 1 we will discuss on this topic only, but later I will discuss the part 2 in part 2 and part 3, that different aspects of different kinds of oxidation reaction. So keep watching on my channel, keep watching to my channel. Okay, so let's start. This is selenium dioxide oxidation. Okay, so now see the substrate. Substrate is given like this one. I am writing the substrate here, and CO2 like this. Okay, this is a substrate, and you have given this reagent SiO2, so it is selenium dioxide, and the catalyst which is used in this reaction, that is tertiary butyl hydroperoxide. Okay, TBuOOH. Like now see how the naming is occurred. That is we know that H2O2, that is hydrogen peroxide. In there is a OH part is fixed, one hydrogen is replaced by this tertiary butyl group, so that's why the name of this compound is tertiary butyl hydroperoxide. Okay, so this is used in this reaction as a catalyst. So tertiary butyl is as a catalyst. Okay, so this is used for after the selenium dioxide, after the oxidation, after its oxidation, it to regenerate this SiO2 used by this type of catalyst, that is tertiary butyl hydrogen peroxide. Okay, so now see the mechanism, how the reaction proceed. Okay, so reaction mechanism is, now the structure of the SiO2 is like this. Okay, now see there is a different kind of mechanism of this reaction. There is a two types of, you may say that two types of pericyclic reaction. Okay, or there is one, in first step there is a in reaction, and in the second step there is a possibility, or there is a chance, that is called 2,3 sigma tropic rearrangement. Okay, so two different type of pericyclic reaction and occurs during this whole mechanism and after the product form to till the product formation. Okay, so now see there is a first step that is used, the reaction that is used, it is in reaction in the first step. Okay, so here is a lone pair of oxygen, it can abstract the proton from here, and these bonds go here, and this double bond will attack to the selenium atom. Okay, so now after that the product, the formation of the product, there is a double bond here, and this double bond will break and it's bonded with selenium, and this goes to that side, and so this is OH and there is a double bond O. Now this is CO2Me. Okay, now see, this is the first step, that is in reaction. Okay, now the second step, that is 2,3 sigma tropic rearrangement is occur. 2,3 sigma tropic rearrangement. Okay, so now see how the 2,3 rearrangement will occur. Now if we numbering from here, that is, it is 1, it is 2, and this is 3, and this is 1 and this is 2. Now this bond will break, and after that the bond formation will occur between 2 and 3, and this is how the reaction proceed, and that's why the reaction is called typically called 2,3 sigma tropic rearrangement. Okay, now see how the mechanism, how the reaction proceed. Okay, so this has a lone pair of electron and okay, so lone pair of electron, 2 types, and the mechanism of this 2,3 rearrangement is this bond will attack on the oxygen atom, and these bonds will go back here, and these bonds will go up here. Okay, so now see, after the 2,3 sigma tropic rearrangement, there is a formation of this bond. Okay, let's see OH. Now this bond is attached to this system, and this is the selenium oxygen bonds will go back here. So the selenium carbon bond is breaked, so there is a formation of, now this is a double bond, and this is CO2Me. Okay, now see, after that in the reaction medium water is present, so this selenium oxygen bond will keep, this is ether, this is ether bond, this is called selenium, sorry, not ether, it's ester, this is called selenium ester, and the oxygen state of selenium is +2. Okay, and here is this part, this component is called allyl selenic acid. Okay, now after the hydrolysis there is a formation of, there is OH, CO2Me. Okay, so this is your overall product. Now see, if the selenium dioxide, percentage of selenium dioxide is much higher, then this allyl alcohol will also converted to aldehyde. But if the selenium dioxide percentage is lower, that is 4 to 10 or 5 mole percent of selenium dioxide is used in the reaction, so there is then this allylic alcohol is the last step, and this allylic alcohol is the product, major product. But if the selenium dioxide is contains selenium dioxide present in higher amount, then this allylic alcohol also converted to the aldehyde. This writing here, and this is also converted into aldehyde. Okay, if the percentage is lower, that is 10, 5, whatever it is, then the final product is this, and if the percentage of selenium dioxide is higher, then this product is like this. Okay, so this is the overall mechanism of selenium dioxide oxidation. Now we are coming to the next important reaction, that is COREY-KIM oxidation. Okay, which is very much important for competitive exam. So this is called COREY-KIM oxidation. Now see what type of reagent is used in this COREY-KIM oxidation. So first of all, in this type of reaction, oxidation reaction, the reagent which is used is NCS. First of all, this is NCS. Okay, so what is NCS? So NCS is nothing but N-chlorosuccinimide. So what is N-chlorosuccinimide? This is called N-chlorosuccinimide. N bonded with chlorine, so N chloro, this is called N chlorosuccinimide. This is N-chlorosuccinimide. Okay, so this is used in this mechanism of in this type of oxidation, NCS, and there is also reagent used, that is Me2S. This is 1, this is 2, Me2S, that is called dimethyl sulfide. So, okay, now another and the different type of solvent will like toluene, DCA, different type of solvent is used in this reaction. And the important thing is that the base, you have to put a base. The base is like trithylamine. Okay, so you must put a base. If you not put the base, then there is a different type of product will occur. I will explain all those things. Okay, so let's start and how the let's see how the mechanism proceed. Okay, so now see, I am writing a compound like this. This is primary alcohol, 1 degree. This is primary alcohol, and you have given a NCS and Me2S, and then the solvent in number 1 and number 2. You have used a base like 83N. Then your product, after the this kind of this kind of reagent, the product of your is this, like this. This is aldehyde or CHO. Sorry, there's a mistake. Or CHO. Okay. Now see, if this primary alcohol, if there is a secondary alcohol is used, or another prime here, this is called secondary alcohol, the same reagent condition, then there is a different product this is aldehyde, and then if this 2 degree alcohol is used, then your product should be a ketone. Okay, now see how the mechanism of this reaction, overall mechanism is proceed. Now see, now what is the mechanism? Okay, now I am taking as a consideration of the second 2 degree alcohol. Okay, so 2 degree alcohol I am taking here, and this is your N-chlorosuccinimide. Okay, and you have given this SME2S. Okay, SME2 or Me2S. So sulfur has a lone pair of electron. It can attack over this chlorine atom, and this bonds will breaks here. Okay, now see what product formation the product here, this one and this one. So this is a positive charge over the sulfur atom, and after that, so this leaves from the system as a nitrogen, negative charge over the nitrogen. So this one is a negative charge. So now this negative charge will attack on the sulfur atom, and the Cl leaves from the system, so minus Cl minus. Okay, now after that the product which is formed here is like this, Me and sulfur, and there is a bonded with nitrogen, this one. Okay, this is positive. Now we are taking into consideration that we use the second degree 2 degree alcohol. Okay, so 2 degree alcohol like this, R and R prime, and there is an oxygen lone pair of oxygen. Okay, over oxygen atom. So this lone pair will attack to the sulfur atom. Okay, to the sulfur atom, and these bonds will go back. Okay, now see this R and R prime, here is hydrogen, I'm writing here like this way, and this is oxygen, plus here is a positive charge, and this is Me and Me. Okay, this is your positive charge. Now see, you have to put a base. Now here is the role of base. Okay, now this nitrogen 83, and nitrogen has a lone pair of electron. So this lone, okay, okay, I missed here. This is this type of compound is named as alkoxy sulfonium salt. Okay, this is overall compound is called, this is the alkoxy bond and the sulfonium is here. So the alkoxy sulfonium salt is called alkoxy sulfonium salt. Okay, now the base has an important role here. This base is abstracted from here. This is just because of the acidic one, and this bond will go here and this one will go here. Now what will be your product? That is a ketone. That is a ketone like this, and the free Me2S will regenerate. Me2S is regenerate. Now see, now here is an important concept is there. If you do not put the base in the reaction medium, then how what type of product will occur in if you do not put the base? Now see, I am taking consideration a compound like this. So this is a allylic alcohol. If we put NCS, Me2S, and there is a different type of solvent, that is CH2Cl2 I am writing here. This is here 1 and this is here 2. We have to put base like this. So what will be your product? You can easily say that after knowing this mechanism, you can easily say that there is a CHO. Allylic alcohol will oxidize to CHO. Now if this in the second step I am writing here, if the base is not used, that is I am only writing here, that is NCS, Me2S and the solvent CH2Cl2. Now what will be your product? Now see, here is an important interesting product will occur like this. Okay, now this is a Cl. Now see, this is the product. Now how this product will occur? Now before the reaction of this whole NCS or Me2, your product is alkoxy sulfonium salt. Now here also there is a formation of this alkoxy sulfonium salt. Now see, if the alkoxy sulfonium salt is okay, I am writing this 2R as this is this one, and this Me, and this is Me. This is your positive charge. Okay, now if so, okay, I am writing here is a mistake, or not mistake actually. This N minus will abstract this proton from here, that is like this way, so to neutralize this oxygen atom. So here is also, this is not there, I am missed it from here. Now if the base is not present, then the free Cl minus, then the Cl minus is free and it's present in your system. So this Cl minus will attack in this side, and this type of remove this is called sulfur oxygen bond is highly stable, so it will remove from the system. Then this is called, I think you know, this is dimethyl sulfoxide, that is DMSO. Okay, this will leave from your system. Now see how the reaction will proceed. Now this similar mechanism is also present here. So okay, so this is your overall COREY-KIM oxidation. I think this video is very much useful for you, and if it is useful for you, then please subscribe to my channel and share it with your friends. Okay, so second part will also come in the next days. So okay, that's it for this video. Thank you so much for watching.